Hello, everybody. Thank you for coming to this FOBK webinar. We have a very exciting set of speakers for you today. But let me begin firstly by thanking Think City for hosting this webinar on behalf of Friends of Bukit Kiara. We're very grateful for that. I should begin with a word initially about the video you just saw. As you can see, this was actually prepared originally as a introduction to our event, Earth Day event in 2020, which was supposed to have been held last Sunday. But because of the shutdown, we couldn't go ahead, and everything has gone online. But one of our volunteers, Ming Chua, actually prepared this. I think it was a good video. It gives you an idea of the kind of things we do. So just as a background, so let me just move on with that. We are going to be talking to you today about fireflies, and as I say, we have two speakers. Before I introduce Dr. Nada, a bit of history. Sometime in 2018, with our partners, MNS, we confirmed that Bukit Kiara is the home to the largest firefly larvae genus called the Lumpigera, which was really caught our imagination. And that has actually unfolded a whole series of activities which we have been doing around this subject. And so hopefully, you'll gain something from that today. I'm about to introduce Dr. Nada, but one of the things we've realized today is that the internet has been quite unstable. So bear with us if there are issues with the quality of sound or picture or whatever. In any case, at the end of this session, all of you will be sent the slides of the presentation, so you can have a look at it, and you will also be able to replay the videos. So bear with us, and let me begin. The first speaker today is Dr. Nada Badruddin. She is from FREM. Let me just give you a bit of background to her. Dr. Nada, are you there?
Hello.
Hello. Hi, Dr. Nada. Yes, thanks. Okay. Dr. Nada completed her bachelor's degree in applied entomology from the University of Science Malaysia and was appointed by the Forest Research Institute Malaysia as a research officer in 2004 to work on fireflies of the Selangor River. A focus of research in FREM expanded from understanding the ecology and biology of riverine fireflies to particular species, focusing on inland forest fireflies of the tropics. She completed her master's degree in 2011, which focused on understanding the lesser-known life stage of the riverine firefly and larva. She was also part of the team that developed the non-destructive methods to monitor riverine firefly population of the Selangor River, a methodology which continues today to monitor the firefly population in that area. After completing her postgraduate study, her focus of research shifted to the inland forest fireflies as a group, which is relatively understudied compared to the riverine fireflies. Knowing the complexity of the tropical forest, the rich resources it supports, and the increasing threats our forests are facing, the benefits of exploring this group of fireflies was identified. Keeping this in mind, she pursued her doctoral degree in Sheffield to study the biodiversity of fireflies in different forests of Malaysia, with emphasis on identifying the influence of logging and elevation on inland tropical forest fireflies and their diversity. With that, I'd like to ask Dr. Nada to take over and do her presentation. Thank you, Dr. Nada. Go ahead.
Okay, thank you, Dr. Kriban, for the introduction. Hello, everyone. Good afternoon. So today, I know this past week the popular subject is COVID-19. However, as we stay at home, hashtag stay at home, it would be nice if we could shift our minds to another topic which is quite different from COVID-19, but hopefully could make us appreciate the natural gem our country have. So what I'm referring to is actually the fireflies. So the title of my presentation for today is The Iconic Fireflies, a Measure of Nature Conservation in Malaysia. So fireflies has never ceased to mesmerize people, either the general people or the scientists. Over the years, my work has been centered on these charismatic insects, and today I wish to share with you an overview of the fireflies, paying attention to the Malaysian fireflies, their biology, habitat, their unique features and iconic characteristics, and I will also touch on the potential threats that they may be faced caused by changes to their environment. So fireflies are from the order Coleoptera in the family Lampyridae. So there are more than 2,000 species around the world, and in Malaysia we can group the fireflies based on their behavior, that is on the fireflies. How are these two groups different from each other? First, let's look at their habitat. So the congregating fireflies have a more confined area that they call home. They inhabit the riparian area of the river, especially where there is high and low tide cycles. The solitary fireflies, however, are more distributed, so they can be found in different forest types, especially the inland forest. For example, if we look at the forest type across elevation, there are at least 5 types of forest, and the solitary fireflies are present in the 5 forest types. Next, we can see the difference in their light display. So light display is one way fireflies communicate within their species. In the congregating fireflies, their light display is done on trees that line the river banks. So they position themselves almost stationary among the leaves of trees to showcase their light. Congregating behavior means that they display their lights in large groups, and in a good day, some trees could have hundreds of fireflies at one time. So the solitary fireflies, as the name implies, are more of a lone ranger. They do their light display mainly in solo. So you would seldom see solitary fireflies in a large group in a given time or place. Finally, the difference between these two groups of fireflies is based on their diversity. So in the estuarine areas where the congregating fireflies live, we would be seeing between 1 and 3 species in an area, and the maximum that we have recorded so far is about 3 species in one site. In contrast, the solitary fireflies, although small in number, has a relatively higher species composition. We could be seeing about 7 to 9 species in one location. In our country, there are 26 confirmed firefly species in Peninsular Malaysia, and only 5 are the congregating species. In Malaysia, the congregating fireflies that live in the estuarine and riverine area have been studied more extensively, but not comprehensively. Studies on the solitary fireflies in different types of habitats are limited. However, fireflies of the forested area have the potential to be included as an attraction of the ecotourism industry. With a sustainable management, this group of fireflies could be the future firefly watching tourism of our country. Now I would want to bring your attention to the more popular fireflies, the congregating fireflies. So as how they are restricted in the habitat type that they occur in, their distribution around the world is also restricted. The congregating fireflies are only found in between the south part of India, right across Southeast Asia towards Papua New Guinea. So I would estimate around 10% of the total global land area. They live along river banks with brackish water. So what brackish water means is that this river part receives salt water from the sea and fresh water from upstream. They exhibit either synchronous or non-synchronous flashing. What this means is that when they congregate, some species that congregate on trees would be flashing in almost unison, while other species that congregate but they flash almost randomly. So in Peninsular Malaysia, there are 5 congregating firefly species known, and the most popular is the Tharoptic stenna. In 2010, MNS published a poster identifying the congregating firefly sites. They call it as congregating zones. And so far, it was identified 96 areas supports congregating fireflies. Out of these 96, at least 11 sites in Peninsular Malaysia is being utilized as a firefly tourism site. So like any other beetles, the fireflies undergo a complete metamorphosis. So for the Tharoptic stenna, the life cycle is between 5 to 7 months, and most of the lifetime is spent as the predatory larva. So this larva actually lives in the natural vegetation of the river. And as a predator, it preys on small snails, mainly Psychotropis carinata, which we found in Sungai Selangor River. As the larva starts to mature and it will pupate underground in an oval-shaped chamber. So the adults would congregate on trees along river banks, mainly on berembang trees, locally known as berembang, which is a Soneratia cassiolaris. So for the tourism of congregating fireflies, the most popular site is Selangor River in Kuala Selangor. So this area is popular for local and international tourists, and the firefly tourism in Sungai Selangor actually contributes to the socio-economic of the local people through boat trips at night. However, this habitat of the fireflies is actually facing threats. So the major threat for the firefly in the area is actually habitat loss. Habitat loss due to land conversion of natural riverine areas for development, mainly for plantations. The firefly breeding habitat are actually mostly affected by this development. Habitat which is the display remains relatively intact because the berembang tree actually grows at the muddy plain of the river. However, the whole firefly population survival is actually affected by such conversion. The good news is, because of their importance in contributing to the socio-economic of the local people, their conservation is given greater attention. Efforts such as population monitoring, establishing land reserve and habitat rehabilitations are among the efforts conducted to revive and sustain the congregating fireflies in the existing habitat. To assess and keep track of the firefly population in Selangor, FRIM has developed a firefly-friendly method to monitor them on a monthly basis. So we have been doing this since 2006 and hope to continue monitoring the firefly population here into the future. The Selangor state government also has established a protection zone covering the habitat of the Selangor River. So such gazettement actually assist in limiting habitat change, thereby ensuring the firefly population survival in their natural habitat. And then in the protection zone, a large area was reacquired by the Selangor state government to rehabilitate the firefly habitat. So this land is being replanted with natural vegetation such as sago, nibo and figs, and it involves the participation from local agencies, voluntary program of the public, and also a CSR of private companies. Now let's shift our attention to the solitary fireflies. So contrary to the congregating fireflies in the estuary that gather in large numbers, the inland forest fireflies are only solo flyers. So, and also contrary to the congregating fireflies, the solitary fireflies has a more varied shape, sizes, and light flashing patterns, which reflects their higher biodiversity and unique relationship with our forests. So solitary fireflies are distributed around the world, occupying diverse habitat types within the tropical and temperate regions. Their habitat range from open grasslands to dense rainforests, from lakes and streams to apex of mountains. In Malaysia, so far we know they occur in these 5 forest types, and their habitat has shallow streams, area with good amount of leaf litter and herbaceous plants. They also can be found on canopy of trees and are in the vicinity of waterfalls. The solitary fireflies exhibit diverse forms of communication, not limited to light displays. Other forms of communication are emission of pheromone, for example in dry luster firefly, a combination of pheromone and light display, example pyrocilia, and those that communicate only is actually active at night, known as nocturnal fireflies. Those fireflies that only use pheromone are active during the day, known as diurnal fireflies. And there are fireflies that actually combine the use of pheromone and light display to communicate, and these type of fireflies can be active during the day and at night. So like in Malaysia, information on the solitary fireflies is scarce. Like any other low abundance living things, their survival could easily be threatened by changes to their habitat. A potential threat could be for the fireflies in the mountain area. Mountainous regions may harbor endemic species and relatively spared from development and agriculture expansion. Climate change, however, has shown that it affects an upslope range shift of animals across tropical elevation. At the same time, this area can cause, So fireflies of Malaysia sampled across elevation was found to be restricted to certain elevational ranges. This means that they are adapted to certain habitat characteristics, but could be less adapted to other habitat conditions. So as tropical forests continue to be altered, secondary forest is increasingly becoming an important biodiversity conservation area. More evidence has shown that secondary forests support substantial biodiversity. And secondary forest is actually forest that is experiencing recovery from modifications such as logging. So for fireflies, it was found that there are variation in species composition where forests are at different recovery stages. Mainly the firefly species composition in this forest is moderated by canopy closure, leaf litter, depth and proximity to water bodies. So more efforts are there forest and sustain biodiversity example for fireflies. And secondary forests that are easily accessible to the public could be developed for ecotourism and public engagement activities. A few years back, we initiated a study on solitary fireflies in FRAME. FRAME is a tropical research institute with green landscape, forested areas supporting recreational functions. So in this area, we have arboreta, camping site, nature trails and gardens. This area was once comprised of vegetable farms and tin mining undergone replanting of timber trees. Now, Frame Forest area has become an exemplary secondary forest, sustaining good amount of biodiversity. So in our study, we sampled fireflies in 8 nature trails and 5 areas in Frame. From the study, it was identified at least 12 species of fireflies from 10 genera can be found in the forest. In the first weekend of July last year, we also conducted for the first time a date with fireflies of Frame in conjunction with World Firefly Day 2019. So this is the first time we have ever organized a night walk activity specifically to show the participants the beauty and uniqueness of the solitary fireflies. And the participant gave a good positive feedback on the program. So the Bukit Kiara Park actually also have recorded fireflies in the area. So Bukit Kiara Park is one of a few urban forests in our capital city in Kuala Lumpur. And like Frame, Bukit Kiara Park was once an area cleared for agriculture. So previously a rubber estate, now Bukit Kiara Park is being maintained as a green area to recover and regenerate. So far, we know there are at least 5 genera of fireflies occurring in this area. The most appealing firefly in Bukit Kiara is the lamprey jera. So the larva of this firefly is huge compared to other firefly species. So there could be a possibility, like Dr. Kriban said, that this species is the largest firefly species in the world. So lamprey jera fireflies requires about a year to complete its life cycle. The adult males and females is actually totally different from each other, whereby the females remain in larviform shape and can reach a length of up to 10 centimeters. The males are actually able to fly freely and only can reach a size of 2 centimeters in length. So the worm has a black coloration, although it is the same shape for the females, the adult females and the larva. The coloration is different between them, whereby the female has a more of white color. So so this is the final slide before I end the presentation. So I just wish to reiterate again that fireflies is actually one of our natural gems in our country, and we are blessed to have them. By actually placing effort in conserving fireflies, we are indirectly conserving and helping other organisms that coexist in the area of the fireflies. And to sum it up, I think the potential of firefly as a tool in conservation, biodiversity conservation in Malaysia, can be done through education, engagement, and sustainability. And the research here invites multiple approaches we can work on in the future and by making fireflies as the center feature. With that, I thank you.
Thank you so much, Dr. Nada, for that very comprehensive presentation. And also, thank you for highlighting the fireflies in Bukit Kiara. And I know you have been a bit involved with some of the work we have done in the past. And I hope we can continue to carry on the research which we need to do. Before I introduce Thary, I just wanted to say something which is quite interesting. It's been recorded the world over that these little insects, these fireflies, are actually an environmental indicator, as they can only live in a quality natural environment which is clean, which has clean water and fresh air. So that's fantastic, because it does indicate that we do have these conditions in Bukit Kiara, and hopefully we can maintain them. Let me go on to the next speaker. Thary Go, who will be speaking about the. Let me go on to the next speaker. Yeah, I'll be speaking about fireflies, a case study for rewilding. Thary, are you on? Yeah, thanks. Thary Go is an ecologist who is currently completing his PhD on dung beetle ecology and trophic collapse at the University of Malaya. Prior to this, he completed his master's at the same university, investigating the necrophagous fly and beetle communities along an altitudinal gradient. With an interest in beetle communities with an interest in community ecology and beetle taxonomy, his research focuses on how groups of fungi, plants, animals can form complex self-sustaining interactions. As part of the Urban Biodiversity Initiative, UBI, an independent collective of urban biodiversity research and outreach. His novel ecosystems consisting of native and introduced organisms are created in landscapes, as well as using these landscapes as a platform for education and outreach. So without any further ado, can I just hand over to Thary to take it over? Thanks.
Okay, thanks, Dr. Kriban. So today just now Nada was talking about how fireflies in a way help to protect the other animals around the ecosystem. So today I am going to talk about how that happens and what processes do the fireflies influence and what can we learn from these processes. So I'll just preface this a bit to say that I'm not a firefly expert, but I'm an ecologist. That means that I study natural systems. And in this case, one of my specializations is to look at trophic ecology, which is basically looking at food chains. Like what happens when you start affecting food chains. So another thing that I want to touch on today is the concept of rewilding. Rewilding is a very recent development in conservation science. And it is the idea that you can restore wildness through reintroducing native species and reintroducing native processes. So by reintroducing native species, what you do is you can reintroduce functions back to the ecosystem. And Bukit Kiara itself is quite an interesting case study of this, because the fireflies of Bukit Kiara are a native species. They are not like a foreign species from anywhere else. But because Bukit Kiara used to be an agricultural site, it used to be a rubber estate, somehow these fireflies have managed to come back in, or maybe they didn't go away. And it's good to ask that question of what functions do they restore when they come back in, or what functions do they maintain in the ecosystem. So a bit of another warning, sometimes when you get answers, you get a lot more questions, and that's what's going to be happening soon. So rewilding focuses on three main important functions in an ecosystem. And I simplified terms a lot. You can see the more complicated ones in the brackets. So the three things are food chains, disturbance, and movement. And I'll be going through all these three processes and explaining to you how the fireflies affect them and how it does theoretically affect them anyway. So food chains. Many people might not know this, but the firefly is actually considered an apex predator by definition. So fireflies actually have a lot of poison in their body. The light that they have is actually a warning to predators at night that to not eat them, as well as for sexual functions to attract mates. And because it doesn't have any predators, basically a cat or any small mammal which tries to attack a firefly is probably going to get a really, really bad stomach ache, and it'll probably spit the firefly out or never eat fireflies again. So in a way, the firefly is a predator that does not have other predators, and it is basically at the top of its food chain. As Nada mentioned just now, fireflies go through incomplete metamorphosis. That means they start off as a larva, which doesn't look anything like the adult, and they have to go through a pupation stage and then turn into adult. here is a diagram of a different species of Lamprigera, but it still goes through a similar lifespan. And one thing that we believe at the moment is that the adult Lamprigera actually does not eat. We've tried feeding them, and they don't seem to be attacking any snails. But the larvae are quite aggressive predators. And most probably, the larvae of Bukit Kiara fireflies are feeding on snails or worms, these kind of soft-bodied animals. And ecosystem-wise, snails and worms require certain types of habitat to live. Some of these, like the ones on the left of this picture here, mainly fungus feeders. So they feed on rotting fungus, they feed on rotting wood, they're decomposers. So they need some sort of decomposition to survive. Another type of snail is, of course, the herbivorous snails. So some of them feed on algae, which is growing because of moisture. Some of them actually feed on saplings or small plants. So there's a variety of things which are required to have snails in the ecosystem. This is an example of the firefly feeding. There were some questions in the audience just now about what do fireflies eat. So as you can see here, the snail has a shell and that's its main defense, but that is totally useless against a firefly. Because of the worm-like shape of a firefly larvae, it can just like crawl into the snail shell and bite the snail. And the firefly's fangs actually also inject toxins, it's kind of venom, which can melt flesh. So basically it bites the snail a lot and then it kind of liquidates the snail and then it sucks the snail out like snail soup out of a bowl. So you can see that happening in this picture here. Another case here is also, so this here is the giant African land snail, Achatina fulica, this Achatina fulica. It's actually an introduced pest species. In fact, in many farms and gardens, this thing eats all your vegetables. Another type of snails also is this one. This is called Sarika. It's a native snail species. It survives mostly on it. So far, I think it feeds mostly on algae and other small plants. And here is a picture taken from Bukit Kiara, which shows a wild firefly feeding on the snail. So what do we know so far about the food chains of Bukit Kiara? You can see that fireflies occupy a higher role in the food chain, and they feed on a variety of snails. And these snails, in turn, feed on a variety of food sources that include plants, algae, or fungi, and decomposition. So one thing about this concept of rewilding is that when you're doing rewilding, you're trying to create more complicated food chains, because more complicated food chains create more resilient ecosystems. It's kind of the same concept of you don't want to put all your eggs in one basket. When there are more connections in the food chain, it's more stable. If you remove one part of one component, the other components still can survive. Another thing is the concept of umbrella species. So as Nada had said at the end of her presentation, fireflies act as a way to protect other species. So you can imagine the fireflies acting as an umbrella to all the other species which are below it in the food chain. So, if you wanted to do a conservation project and you tell people, I want to protect the snails of Bukit Kiara, likely you're not going to get very good reception. But with a nice charismatic species like a firefly, it can help protect all the steps below it. And that is, in conservation, what we call an umbrella species. Conversely, if we want to understand these solitary fireflies better, we also have to understand what snails are there too, and what snails are they feeding on, and where can they be found, because ecosystems are all connected. So it requires us to understand each step of the ecosystem if we want to protect the whole ecosystem. So the fact that fireflies are predators also relates to another concept, which is disturbance. So in common knowledge, to the layperson, sometimes you think that disturbance is something bad, but in a lot of natural systems, you must have disturbance. Trees must fall, things must die and regrow. Otherwise, a lot of things cannot survive. Otherwise, you get what you would say is a monoculture. And as predators, fireflies introduce this disturbance into ecosystems. So here is a bit of a simulation study. You can see the green, you can see a blue line which represents the snails, and then a reddish line at the bottom represents the fireflies. So when you get too many snails, the population of fireflies increases as well, and that causes the population of snails to go down. And this disturbance creates a stable system in which the number of snails is controlled. And there have been many studies in which predators are removed from ecosystems, and that causes a lot of changes. So here's another example of how predators affect the diversity of the prey species. So you can imagine, you look at the top graph there, you can see that if you don't have a firefly as a predator, what usually will happen is like the most competitive species is going to dominate and crowd out the less competitive species. Maybe they can't eat as fast as the other snails or something like that. They can't breed as fast as the other snails. But when you introduce predators into the system, what happens is that the predator can control the most common species. It puts pressure on the most common species, and that relieves the pressure on the less competitive species. Maybe they have their own natural defenses against fireflies that allows them to survive. So having predators in ecosystems has a trickle-down effect. It increases the diversity of animals, of herbivores. It reduces the number of the dominance of just single species of herbivores, and that in turn increases the diversity of plant life because there's more varied pressure on the plant life instead of just one dominant herbivore eating everything. And in ecology, this is a concept that we call a keystone species. So this concept comes from architecture, actually. So when you're building an arch or a bridge out of stone, usually you have to put a single stone in the middle that's called a keystone, and that holds the entire bridge together, the whole arch together. So if you remove this keystone, what happens is your arch falls apart. And it's the same thing with ecosystems as well. Predators often act as the keystone species, holding ecosystems together. There are some examples of, and these are taken from the Pacific Ocean. One of it is, you can see these starfish in the corner here, this red and blue starfish called pisaster. And it was found that if you remove this starfish from the ecosystem, what happens is that the sea urchins start breeding a lot, and they crowd out the natural algae and everything, and they eat all the algae, and that causes a collapse of everything else. The fish start to reduce, the shellfish start to reduce, all because you lose that one ecosystem. It's also the same with Pacific sea otters. So sea otters live in kelp forests, and they feed on a variety of herbivores, of shellfish, of fish. What happens when you remove the sea otters is that all these things that they eat go out of control, and they start eating up all the kelp, and then they basically start destroying the ecosystem. So what you see is a collapse of the kelp forest. So it could be the case that fireflies might also play a similar role in our ecosystems, controlling snails. So the third concept that I need to talk about today is movement. So there's not much that we know about the movement of fireflies. there's the question: what makes Bukit Kiara fireflies special? Interestingly, we've done quite a lot of work in Rimba Ilmu. You can see that is right in the corner there, right under the word club golf. That small green patch, you can see Bukit Kiara is right next to the Sasak Hatama's word, and at the bottom of that map is Bukit Gasing. And at one point, these all used to be a continuous forest. But at some point, people started chopping it down to make housing estates. Well, it actually wasn't a continuous forest, it was a continuous rubber estate. And people started using this land to build housing estates. They started breaking it up for highways. They built golf courses, So what has happened is that from a continuous patch of green space, it has turned into islands of forests inside urban areas. And interestingly, what you see is that there's a different composition in each of these islands. So how could that be? In ecology, we have known for quite a long time that the size of an island also affects what is there. This is the theory of island biogeography, first proposed around the 1970s by MacArthur and Wilson. So the idea is that the smaller your island, the less animals it can support. And if you look at just the size of the patches, you can see that Bukit Kiara is a much larger patch than the other patches. And possibly, the size of the patch itself allows more species to survive and coexist side by side. Another explanation is an explanation called metapopulation dynamics. Basically, a larger patch can actually act as a reservoir for smaller patches. So it's possible that larger patches are a patch where animals can breed and access. This is what we call a source. And smaller patches are what we call a sink. So basically, if the population in smaller patches is unstable, what happens is that larger patches if there's movement between a small patch and a larger patch, the larger patches can act as a way to re-establish or rescue populations in smaller patches if there is some sort of disturbance or extinction. So interestingly, the fireflies which you do see in the other patches, in Rimba Ilmu, in Bukit Gasing, are ones with more movement. They have more dispersal potential. Basically, the males and females can fly, whereas large species like Lamprigera, the female cannot fly. So it's possible that the amount of movement itself is affecting diversity and is affecting what can be found in where. And we don't know a lot about this. This is still a lot of theory, but it takes a lot more. It takes a lot of study to be able to prove whether the theory is true or not. So, but a big implication of this is that if we maintain Bukit Kiara as a large patch, that means that Bukit Kiara can potentially be a source to rewild other parts of KL. It can be what we call the source, it can be the backup for other patches. Even though if other patches there is some sort of collapse, they can be rescued by the larger patch, as long as there's enough connectivity between patches. So those are the three functions which I was talking about: food chains, disturbance, and movement. And in many ways, if we want to rewild, it has to be more than just planting trees or adopting green habits like recycling or not littering. We need to think about ecosystems. We need to think about ecosystem functions, and we need to think about how can we influence the ecosystem functions, or how do animals that are already there influence ecosystem functions, and what can we learn from them. As I said, a lot of the relationships here, some of them are theoretical, or some of them, they're only from preliminary data. We need more data. And we need evidence before we can make decisions. And we need evidence to see is it true that the ecosystem is following established ecological theory, or is it something new? And if it's something new, then those are incredibly new scientific discoveries. So I'll close this by saying that a lot of textbook rewilding examples are mostly found in Europe or America. In fact, it's quite strange that we frame, which is actually an incredibly successful experiment in rewilding, never gets into a conservation textbook. But could Fireflies of Bukit Kiara one day also be a good case study? If we put that, if we invest that research into it, maybe it's a way forward to understanding how is it that by introducing invertebrate predators into an ecosystem, you'll be able to change the entire ecosystem or be able to increase or create more resilient wild ecosystems. So thank you, and I'll pass this back to Dr. Kriban to start. I'll pass it back to Dr. Kriban. Okay.
Hey, thank you so much, Thary. What a fascinating subject and talk. Yeah, I'd really like to open up this for discussion. So those of you who are listening, please, type in your questions so that we can take this up. But maybe we can start with one or two. Or can I also invite Dr. Nada back on, please? Hi, Dr. Nada. Can you hear us? Okay, great.
Yes.
Okay, excellent. So let's try and start this process. What do you call the first thing is maybe starting with you, Thary. Some of these concepts you are talking about are really quite fascinating. What sort of resources and research and development which will we need to do to answer some of the amazing questions you've raised? And I think this also applies to Dr. Nada because you're doing so much research. So maybe you can just start with giving us a feel for what is required and why we have not been able to go forward.
Okay, I think it's quite uncommon knowledge, but one of the really big issues about looking at things like movement or things like food chain is that it actually takes a lot of very complicated science. It takes a lot of very complicated mathematics. And well, it's a joke among biologists that most biologists take biology because they're trying to avoid high school math. And so in many cases, we actually don't have the expertise to do it. Because I've sat down and actually done all that before. And it's a really big headache, actually. And to get enough data to be able to run those models, it takes up a lot of data. You need years worth of data. You need to look at many different aspects of the ecosystem. You need to have many samples, and again, that takes a lot of cost. That takes a lot of manpower. That takes a lot of long-term. So this is a project that will have to take years to complete, possibly 5 to almost half a decade of research if you want to get really conclusive evidence that you can say, yes, this is the case. And in many cases, there is no incentive for a lot of scientists to do that because a lot of people are chasing, you want to get a promotion, you need to produce papers, and you have to produce papers fast. Therefore, it's very hard to invest that time and to be able to get that. So yeah, there are a lot of cases, but what we really need is effort. It's possible that we could maybe use things like citizen science or maybe work with NGOs like FOBK to get past some of these barriers.
Right. No, that would be very interesting indeed. Dr. Nada, any thoughts on your side?
Yeah, I think I tend to agree with Thary just now that usually fundamental research is usually being sidelined. This is actually why we are not progressing much, is because fundamental research in our country is still limited, and anything has to start from the beginning. So and it's also the factor of cost, and also the we have to commit to the work when it comes to understanding the whole. It's not a one line of understanding. It's a complex mix of different types. So yeah, so that's why we also don't know much yet, but we are moving there. I think we are progressing, although not as quick as we would want to. But I can see that in Malaysia we are more aware of the importance of keeping the biodiversity that we have, things like that. Yeah.
Thank you. Let me just stroll through these questions. There's one which is I think more directed to you, Dr. Nada. It's asking why congregating fireflies have less diverse species than solitary ones, and are they able to produce and why are they able to produce bigger populations?
Yeah, good. It's a very good question. Actually, what we know is that in terms of number, they are larger. Probably because they are. We know so far that for therapeutic standard, they produce a larger number of eggs in one batch, and also I think it's more of the complexity of the area when we compare the inland forest fireflies habitat and the riverine habitat. Probably the difference in the complexity of the area could also explain the difference, but I'm not really sure how although there are diversity that they can produce larger number.
Right, interesting. Any thoughts, Thary?
Well, there is a possibility that, as I said, this has something to do with food chains. So one thing about mangrove ecosystem is that they actually are very, very rich in nutrients because they are at the end of the river. So all the sediments brought through the river and also brought by the sea, it ends up in the mud, and that's eaten by the snails. So there's actually a lot more energy potential in a mangrove compared to, let's say, a small stream. Actually, small streams tend to be very nutrient poor ecosystems. So possibly, as I said, food chains might also be a case in this.
Right, good. Okay, another question maybe for both of you. Justin has asked about are the fireflies which are active during the day easy to spot?
Sorry, what is the question again?
Are the fireflies which are active during the day easy to spot?
In my experience, I have never got the chance to collect diurnal fireflies. But we know that the diurnal fireflies exist in the area because when we go in one area that at night, we can actually collect the larva of the diurnal fireflies. So based on that record, we know that diurnal fireflies exist in the area. Because larvae of fireflies, all species of firefly larvae that we know so far have night organs, so they are active at night. So even though when they become adults, they become diurnal fireflies. They are actually an active larva at night. So that's the only way so far that I know of how to know the presence of diurnal fireflies. During the day, it will be challenging to detect them.
Right. Okay. Great. Thary, any thoughts on this?
No, I've never found them either. So yeah, really hard to see, I guess.
Okay. Another general question about firefly tourism in Malaysia. Is this being organized well? Is it sustainable? Are there any thoughts which either of you may have on this?
So maybe I have in my site, one of my sites that I presented, it listed down at least 11 sites of the river in Peninsular Malaysia that supports firefly tourism. For FRAME, we are currently we have done some surveys in all these 11 sites to see the habitat of the firefly in the area, what sort of species that are present, And also, we also see the approach of the tourism that is being conducted in the area. What we can conclude is that firefly tourism, the way we conduct that we are with conservation, firefly conservation, and firefly tourism guideline, specifically more towards the congregating fireflies, and we hope this information would be shared with those people that is conducting firefly tourism across our country, especially in Peninsular Malaysia. Yeah.
Well,
Right.
I think firefly tourism. I think firefly tourism is quite good. I mean, people have done it in these riverine areas, but there's still a lot of potential of these inland fireflies. I think when you talk to people and you show them like a very large firefly, actually they get very excited. So there's potential, but I think people just are not aware that it exists, and therefore efforts like what FOBK is doing have a lot of potential in the future.
Yes, I think so. I mean, I must say that this activity around fireflies has energized quite a lot of our members. In fact, over the last couple of years, we've got a pool of ambassadors we have trained who can take people on walks and give some information about fireflies. So it's been a interesting process, and I'm sure this is something which can be developed further. But Thary, one of your last points earlier was that you were saying that there could be some way that to move along some of this research and development is to have a more citizen science type approach. Can you elaborate a little bit more about that? I mean, okay, for an organization like, say, Friends of Bukit Kiara, what can we do? Can we do some parts of this where our members or our supporters could come and assist with this kind of investigations and so on?
Yeah, so citizen science approaches are still very new in Malaysia, but if you look at examples in Europe, America, in terms of like conservation of animals like monarch butterflies and birds especially. So there's a very big birding community in Europe, and they've been collecting data. In fact, if you look at a lot of ecological literature in Europe, a lot of the data is collected by citizens as well. So you can see like the very big trends over a very large area if you're using data collected by just common citizens. As long as you have good protocols, basically you have very well-defined protocols, you got people to take care of the group and make sure that they're following the rules, and somebody to basically you just need a referee on board to be able to verify the data and all that. Then it's possible to also bring, as I said, you need a lot of manpower to be able to run a big project to get a lot of information. So that's one way to do it, but you need to have that the system in place. That's the most important part.
Sure. No, that's
like,
fascinating.
You can do like walks and stuff like that, and as you do the walk, you just collect the data.
Yeah, that's fascinating. Actually, maybe that's something which we can sit down with both of you and come up with some protocols which we can actually develop. Dr. Nada, you're doing a lot of research as well on the riverine, particularly the riverine species. What can we do on the land-based species? I mean, is there other things which we need to do and should do?
I think the difference between, because fireflies in the riverine, as we know, when it comes to we are more, there's less species, so we can focus on one species and it can actually more or less reflect the condition of the habitat and so on. When it comes to fireflies in the inland forest, for example in Bukit Kiara and in other inland forests, we have many species, and with many species means a lot more information that we need to know. So maybe if we want to approach, to include inland forest fireflies as a way to encourage citizen scientists, that we have to maybe identify one species rather than want to know all the species and trying to understand everything, because it's very complex. And like what Thary said, it requires a lot of information. So maybe we can start off at Bukit Kiara has a good can be a good place to start something like this, initiative like this, because we know that Lampreygira occurs in here and is some a good accessibility. So again, it could be a starting point for to initiate this sort of things. But it's focused on one species to start off. I think start with one species first.
Hey, well, hey, thank you so much, guys. We are actually just out of time. So can I just thank both of you for a really interesting session, and I'm sure we will be meeting up again soon to take things forward. So thank you, and you can actually switch off your videos now.
Okay, thank
Thanks.
you.
Yeah.
Yep.
Thank you, everyone who has been, all of you who have been watching this, and we are about to end. I just want to finish off with a few pointers. Firstly, I think please go ahead and check our website. Some of you have asked about, are there any more activities around fireflies? Please look at our website and also contact FRIM directly. I'm sure they will also be having some activities along these lines. Go to our Facebook. A lot of the information and activities are there. We will end the session now with a short video. So stay on. I'll switch off in a minute. And thank you again to Think City for helping us to put this together. I thank you all of you who've joined, and please get involved. Come and join FOBK. Be involved in the Firefly issues. Become one of our ambassadors to take our members and supporters on walks and so on. Thank you again, and please watch the video. This is a short thing from Hannah Yo. She's our MP for Segambut, and Bukit Kiara is in Segambut. She's just done a video to show her support to Bukit Kiara and also to FOBK. Thank you again. Bye for now.
Hi, my name is Hannah Yo and I'm the Member of Parliament for Segambut. I want to congratulate Friends of Bukit Kiara for the wonderful works that they have been doing. Remember, it is the duty of everyone to preserve the environment, and it does not rest on the shoulders of the government alone. As the Member of Parliament for Segambut, I will continue to fight for Bukit Kiara to be gazetted as a green lung and also for Taman Rimba Kiara to be preserved as a park. Remember, it is the duty of everybody to hand over Mother Earth to the future generation, greener than what we have today. Happy Earth Day, everyone.